Hi, I'm Patrick Reagan. Welcome to Networking Part 13, Troubleshooting Networks Part 2. In this video, we continue our discussion on troubleshooting networks with a focus on troubleshooting specific scenarios, including intermittent connectivity, slow network speeds, jitter, and latency. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Client connectivity problems have many signs, including Windows alerts in the system tray, or you cannot access websites, shared files, network printers, or run applications to depend on the network. A Windows alert for limited or no connectivity or no internet access means your device is connected to your local network, Wi-Fi or Ethernet, but cannot reach the internet. Verify that your switch and router is running and is connected properly. If you're connected to a local network but cannot access internet resources, check your internet routers to make sure it is running, configured properly, and has internet connectivity. And check for ISP outages. Verify that your firewalls and antivirus software is not blocking internet access or blocking access to certain sites, including checking your corporate or internet firewall, check your firewall on the host computer, and check your antivirus software package, including any built-in firewall. Check to make sure you have a valid IP address, subnet mask, default gateway, and DNS server configured. If your assigned IP address begins with 169.254 with the subnet mask of 255.255.0.0, the system is not connecting to a DHCP server to get a leased IP address. Common causes may include DHCP failure that may be caused by the DHCP server or devices are down. Check network connectivity issues between the client and the DHCP server. And on the local subnet, check the router, whereas the IP helper or DHCP relay agent is not forwarding the DHCP broadcast request to the DHCP server. Address pool exhaustion in DHCP occurs when the DHCP server has no more IP addresses available and its configured pool to lease to new clients. This means that devices requesting an IP address will not receive one, resulting in network connectivity failures. It is caused by too small of a scope or pool, IP address hoarding where devices hold on to leases longer than necessary, unauthorized rogue devices, and improper reservations. An IP conflict occurs when two or more devices on the same network are assigned the same IP address. Since each IP address in a network must be unique, a conflict prevents one or both devices from communicating properly. IP conflicts are caused by static IP overlap with DHCP, where devices manually set up to an IP address that's also in the DHCP pool, duplicate static configuration, where two devices are manually configured with the same IP address, cloned VMs or images, where virtual machines or system images are deployed without changing IP settings, multiple DHCP servers where more than one DHCP server hands out overlapping IP ranges, and VPN or subnet overlap where a remote client or site shares the same subnet range as the local network. To troubleshoot duplicate IP addresses, check your IP addresses to see if misconfiguration, ping an IP address before static addressing to see if it's already being used, ping the IP address and check your ARP table and find the MAC address in your switch MAC table, and use a packet analyzer to capture the DHCP process to see what DHCP servers are responding. To troubleshoot intermittent wireless connectivity, try restarting your modem and access point or router and checking for loose or damaged cables. When rebooting, wait 30 seconds, then plug them back in, starting with the modem and then the router. Then check if the issue is device specific by testing another device on the network, and verify there are no wireless interface sources like microwaves or other devices nearby. You should also update your network adapter drivers, router firmware, and antivirus software. If the problem persists, contact your internet service provider or ISP to check for outages or line issues. Check for wireless interference. On your device, update your network adapter driver, especially if the issue is limited to one device. Log into the router's management page to check for and install any available firmware updates. Check for malware or viruses by updating and running antivirus software. On your device, try forgetting the Wi-Fi network and then reconnecting to it. Use network commands such as ping and traceroute to diagnose network performance and identify potential bottlenecks or points of failures. In Windows, you can use the built-in network troubleshooter or reset your network settings to their defaults. Similar to wired networks, there's a limited amount of frequencies or channels and an increasing number of wireless devices. Not everyone can talk at the same time. Even nearby access points that use the same frequencies can cause interference. Most access points can monitor frequency usage and automatically move devices to unused space. One important reason to choose newer equipment that supports the 5 GHz and 6 GHz frequency band is that the signals on these bands have a shorter range and are therefore less likely to create and pick up interference from networks running on older equipment that uses the 2.4 GHz band. Other devices that may cause interference because they use the same frequency are separate wireless networks in your own home, next door, or in nearby offices, Bluetooth, baby monitors, walkie-talkies and other radios, cordless phones, microwave ovens, outdoor microwave links, fluorescent lights, and WiMAX. Also, obstacles can stop radio waves or reduce the reach of radio waves. When creating a wireless infrastructure, you need to check to see if you have sufficient wireless coverage. To check for insufficient wireless coverage in the network, physically walk around your area with a connected device, observing the signal strength indicators on your device, usually represented by bars, while noting any significant drops or dead zones. If you find that you have insufficient wireless coverage, try the following. Reposition your access point. Try placing your router in a central location away from obstacles. Adjust router settings by changing the Wi-Fi channel to a less crowded one. Upgraded your router with more powerful antennas or a newer Wi-Fi standard. Or add a Wi-Fi extender to boost signals in weak areas. For larger areas, consider a mesh network system to provide more even coverage. To troubleshoot slow network speeds, first restart your router and modem, then run an online speed test to compare your speed to your plan. For your client, check your device's network settings and hardware, try rebooting your client computer or device, make sure your network drivers are up to date, check your machine for any bandwidth-heavy programs or file-sharing applications, run a security scan on your computer to rule out viruses or malicious software that can be consuming bandwidth, and consider using a wired connection to rule out wireless problems. For your wireless access point or router, investigate potential Wi-Fi issues like interference, distance from the router, or too many connected devices. Investigate your Wi-Fi environment by checking router placement and moving your router to a more central location away from walls, floors, and cabinets, which can weaken the signal. Minimize signal interference by looking for cordless phones, baby monitors, and other electronic devices that can interfere with the 2.4 GHz Wi-Fi band, and consider changing your Wi-Fi channel in your router settings to a less congested one. Check for devices with excessive network usage. Close bandwidth-heavy programs or file-sharing applications. Ensure your Wi-Fi is password protected with strong encryption, as an insecure network can be used by unauthorized users, slowing down your connection. If the issue persists, check for viruses, update your router's firmware, or contact your internet service provider or ISP to inquire about outages or network congestion on their end. Ensure your modem is compatible with your internet's plan speed. You may need to upgrade for higher speeds. Jitter is the variation in the arrival times of data packets sent across the network, causing inconsistent network latency and negatively impacting real-time communications like VoIP and video calls. This unpredictable delay can lead to issues such as garbled or dropped audio in calls, pixelated or blurry video quality, and lag and disruptions in online gaming. If you miss a packet for phone calls, video calls, and live videos, there's no retransmission, and there's no time to rewind your phone call. To troubleshoot jitter, test your connection's quality by using online speed test tools to measure your jitter, which is often displayed in milliseconds. A health score is generally below 30 milliseconds. To help isolate the problem, try using a wired connection, since wireless connections can be more susceptible to interference, which contributes to jitter. Check your router settings and configure quality of service or QoS settings on your router to prioritize real-time data like VoIP and video traffic. Ensure your internet connections has enough bandwidth to handle your real-time applications. Disable or pause automatic software updates and background downloads, as these activities can consume bandwidth and cause network congestion. Make sure your network equipment isn't outdated. If your router or other network equipment is outdated, it may not be able to handle traffic efficiently. Consider upgrading to a more powerful router. Try using a Jitter buffer, which has a small temporary storage area and networking devices that stores incoming data packets to compensate for jitter. Jitter buffer, which can help smooth out variations in packet arrival times by storing packets briefly and reordering them before delivering them to the application. High latency is a network delay or lag that occurs when there's a noticeable delay between the user's request and the network's response, measured in milliseconds. Signs of high latency include causes slow website loading, choppy video calls, laggy online gaming, and overall poor application performance. To troubleshoot high latency, restart network hardware including your router and modem, switch to a wired connection where Wi-Fi can introduce instability and latency, so connect directly with an Ethernet cable for a more stable, faster link. Close bandwidth-heavy applications. Streaming, large downloads, or other devices on your network can hog bandwidth and increase latency. Check for other users on your network and their activities. Use network tools such as ping, traceroute, and path ping to measure the round-trip data for data packets to reach its destination and return, providing a latency measurement. Update router firmware to ensure it's running the latest software. Check for outdated or overloaded hardware like switches or routers that might be a bottleneck. Scan for viruses, as malware can consume network resources and increase latency. A speed-tested networking measures the performance of an internet or network connection. It evaluates key metrics such as download speed, upload speed, latency, and sometimes jitter and packet loss. These metrics help assess the quality and capacity of your connection, which is useful for troubleshooting, verifying ISP for performance, or planning bandwidth usage. The table shows various speed characteristics including download speed, upload speed, latency, and jitter for home. Here's a table that shows various use cases with the download upload speed, latency, jitter, and packet loss for enterprise environments. And here is a table showing minimum requirements for use cases such as general office use, VoIP or video calls, cloud file sharing, and remote desktop usage. Common command line diagnostic speed tests include speedtest-CLI, iPerf3, NetPerf, and NutTCP. There are many internet speed test sites that can be used to test your internet speed, including Speed Test by Ookla, Google Internet Speed Test, and Fast.com Internet Speed Test. A good download speed is at least 100 megabits per second, and a good upload speed is at least 10 megabits per second. With 100 megabits per second, you can watch Netflix or YouTube, attend Zoom meetings, and play most online games on several devices at the same time. Poor VoIP quality manifests as choppy audio, garbled words, long delays, or dropped calls due to network problems like insufficient bandwidth, network congestion, high jitter, packet loss, or poor network configuration. Troubleshoot poor VoIP quality. Perform a speed test to ensure your internet's connection meets the minimum requirements for VoIP, typically 100 to 150 kilobits per second upload and download per call, and to identify potential bottlenecks or unstable connections that might be causing packet loss or high latency. Configure your router's quality of service settings to prioritize VoIP traffic over other data, ensuring voice packets receive dedicated bandwidth. If you're on Wi-Fi, Connect your VoIP device on computers directly to the router with an Ethernet cable, as wired connections are more stable. Disable heavy applications during calls, close unused browser tabs, pause large downloads, and limit other bandwidth intensive activities. Restart your modem and router to clear temporary network issues. Ensure your headset is plugged in securely and functioning correctly, and adjust volume levels. Check for and install the latest firmware or software updates for your VoIP phone and other network devices to fix bugs that affect call quality. Try using a Jitter buffer, which has a small temporary storage area in networking devices that stores incoming data packets to compensate for jitter. Your VoIP service allows a larger jitter buffer can compensate for packet arrival variations, though this may introduce some latency. Port flapping, or link flapping, occurs when a switch's port's connection rapidly toggles between an up and down state, causing network instability and connectivity issues. It's often caused by physical link instability, such as faulty cable, an improperly seated module, or a bad SFP transceiver. To verify port flapping and identify which ports are flapping, you can review switch logs, looking for back-to-back up and down entries in the switch system logs. To troubleshoot port flapping, check physical cabling and connections, including inspecting cables and looking for damaged, non-standard, or unsupported cables, and replace them, and ensure network cables are securely and correctly plugged into the switch port and the connected device. Test cables by trying a different cable to rule out an issue with the current one. Ensure any small form factors, pluggable, or SFP transceivers or network modules are correctly installed and seated. Verify device configuration, including speed and duplex settings. Ensure the switch's firmware is up to date to resolve any software bugs or glitches. If you have multiple switches or other devices like VoIP phones, you'll have to check for potential loops. Consider if the device is overheating or experiencing power-related issues, which can contribute to hardware malfunction. Run any available hardware diagnostics on the switch or cable to identify faulty components. If you exhausted other options, contact the device manufacturer's support for further assistance. In networking, an authentication failure is an unsuccessful attempt to verify users or device's entity, most commonly due to incorrect credentials, but also caused by network issues, expired tokens, clock skews, or server-side problems. Common causes include incorrect credentials, with the most frequent cause is a typo in a username or password. Accounts with expired passwords cannot be used for authentication. Multiple failed login attempts can trigger a security measure to lock your account. Connectivity problems between your device and the server can prevent successful authentication. The authentication server might be down or experiencing technical difficulties. System clocks between the client and server are too far apart, which is common with Kerberos, Radius, or certificate-based logins. Misconfigurations of the network device, like a router or other device settings, can cause failures. Your device and router may be using different security protocols, like WPA2 versus WPA3. Misconfigured authentication protocols such as the wrong EAP type in Wi-Fi, mismatched hashing algorithms, or LDAP/AD binding errors. In token-based systems, an invalid or expired token can lead to failure. Policy restrictions such as an account is not allowed for certain IP ranges, time, or devices. Network path problems include firewall or ACL blocking authentication ports. To troubleshoot, start by confirming correct username and passwords, restarting your device and router, and forgetting the network on your device to re-enter credentials. If these steps don't work, check for expired passwords, locked accounts, time settings, incorrect router security settings, or problems with the network or authentication server itself. Question: a small office has a wireless network with several access points for roaming laptops use. Users occasionally report that the wireless connection drops or becomes very slow. Users have confirmed that this issue only happens when connected to the office wireless network. Which of the following will most likely be the cause? Answer: device interference. Question: The owner of a restaurant reports that wireless network connections are lost intermittently throughout the day. Which the following steps should a technician take to troubleshoot the issue? Choose two answers. Answers: identify the location of devices that utilize 2.4 gigahertz and map all of the wireless signals in the restaurant. Question: you're troubleshooting a wireless network issue. The users are all connected to the network, but the throughput is slow and the connections often drop. Which of the following should the technician check first? Answer: channel interference. Question: a company in a large building uses a wireless network for its workstations. After a new company moves into the building on the floor below, the old company's wireless network begins experiencing connectivity issues. Which of the following is the most likely cause? Answer: external interference. Question: a user reports limited or no connectivity on a laptop. The technician runs ipconfig/all with the following results: IP version 4 connectivity, limited or none, IP version 4 address 169.254.254.1 with the subnet mask at 255.255.0.0 and no default gateway. Which of the following is the most likely the cause of the issue? Answer: DHCP failure. Question: a remote user called the help desk to report a notification indicating there's a limited or no connectivity. The user can access local file folders and other local machines, but none of the organization's servers or network items. Web pages do not appear to function either. Which of the following is the most likely the cause of this issue? Answer: the user's internet connection is down. Question: the user reports intermittent connectivity. The technician checks the network logs and sees the following output as shown on the screen. Which of the following is the most likely reason for this issue? Answer: port flapping. Question: while on a VoIP call, one user is unable to understand the other because the audio is breaking up. Which the following best describes what is occurring on the call? Answer: high latency. Question: a new computer was plugged into a port that was used by a legacy network printer prior to the completion of an office remodeling project. The user who was assigned to a new computer has been reporting an issue with slow network speeds. You verified the NIC is functioning correctly and the drivers are up to date, and then swap out the Cat6 patch cable. However, the issue persists. Which of the following troubleshooting steps should you take next? Answer: check the speed and duplex settings on the switch. For more information, visit these sites. In summary, if you don't seem to be connected to the network where you cannot visit any sites or access any network resources, you should make sure you're connected to the network. When not connected to the network, make sure you have a valid IP address, subnet mask, default gateway, and DNS server configured. If your assigned IP address begins with 169.254 with the subnet mask at 255.255.0.0, the system is not connecting to a DHCP server to get a leased IP address. Since each IP address in the network must be unique, a conflict prevents one or both devices from communicating properly. A Windows alert for limited or no connectivity or no internet access means your device is connected to your local network, Wi-Fi or Ethernet, but cannot reach the internet. When troubleshooting intermittent wireless connectivity, check for wireless interference, including looking for other devices and wireless access points that use the same frequency. A speed test in networking measures the performance of the internet or network connections, which can be used to evaluate download speed, upload speed, latency, jitter, and packet loss. Jitter is the variation in the arrival times of data packets sent across a network, causing inconsistent network latency and negatively impacting real-time communications like VoIP and video calls. High latency is the network delay or lag that occurs when there's a noticeable delay between a user's request and the network's response, which is measured in milliseconds. Port flapping or link flapping occurs when a switch port's connection rapidly toggles between an up and down state, causing network instability and connectivity issues. In networking, the authentication failure is an unsuccessful attempt to verify users or device's entity, most commonly due to incorrect credentials, but also caused by network issues, expired tokens, or server-side problems. Thank you for watching this video. This completes the networking series of videos. The next series will be virtualization and cloud computing. If you like this video, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.